Hey guys, HackerSploit here, back again with another video. Welcome back to the TryHackMe series. In this video, we're going to be taking a look at Kenobi. So this is going to be part of the offensive rooms, that you have on TryHackMe. Now, the reason I actually want to go through this particular room is because it covers one important technique or one important privilege escalation technique on Linux, and that is the exploitation of, SUID binaries. And we'll get to that shortly. But again, it also covers, various important aspects of enumerating services like SMB on Linux, and of course, manipulating or exploiting a vulnerable version of ProFTPD. So overall, a very, very good introductory box to Linux exploitation and privilege escalation. Now, I've already started it and I have the IP over here. I've already deployed that, so we can actually get started right over here. So in regards to the first two questions, you can see I've already performed the nmap scan and we have about 7 ports open, or exactly 7 ports open. I'll just display the nmap scan for you right over here. So you can see we have a FTP port running ProFTPD 1.3.5, port 22 running OpenSSH. We have a web server, which I actually opened here. You can see it's just a picture of, Star Wars, I guess. I've got to get bashed for that in the comments, but in any case, we have an RPC port as well, running on their standard ports, or running on its standard port, which is 111, of course, and we also have SMB running on 445 and 139, and network file system, or NFS, right over here. All right, so that is essentially 7 ports, which is what I entered exactly. And we can now, take a look at enumerating Samba for shares. All right, so that's the first thing that it actually recommends doing here, because we have, we have SMB running. So if you're not familiar with what SMB is, SMB stands for Server Message Block. Now, this is a protocol that allows, users and, essentially computers on the network to communicate with each other, share files, resources, and printers. Now, this was implemented on Windows, and in regards to Samba, Samba is the Linux implementation of SMB, so it allows Linux systems on a network to communicate with Windows systems or Windows machines. So again, it'll give you a brief description as to what it is and how it works, and the key thing to note here is that it operates based on a client-server protocol or client-server communication model. And again, SMB, as it says, is developed only for Windows. And again, Samba is the Linux implementation. So the first thing it actually recommends that we do is use nmap to enumerate information regarding the actual SMB shares and the SMB users, right? And it's doing this using nmap scripts. So this is one of the great reasons, or one of the great advantages of using nmap, is its quite extensive collection of scripts that allow you to enumerate as much information as possible from your services. So the nmap scripts, if I can just list that out here. So your nmap scripts are going to be stored under the user share nmap scripts directory. And you can see if I type, hit enter, it'll give us a whole load of lists, or actually scripts. And we can use the grep utility to look for exactly the, the service or the protocol that we're trying to enumerate information for. So in this case, SMB, and you can see we have quite a few SMB scripts. And in this case, we're using the SMB enum shares and the SMB enum user script. So in order to use this, all we need to do is say sudo nmap, and then we specify the port here, which is going to be port 445. And we then want to specify the script option, and then we specify our scripts here, which in this case is going to be SMB enum shares. And then we use a comma if we're specifying more than one script for a particular scan. And in this case, it's SMB enum users. I believe that's the correct name. That is the correct name. And then I paste in the IP address and we hit enter. And because I'm running a privilege scan, it's going to ask me for my password. It's going to say we have an issue here. So that looks correct to me. I don't know what I've specified incorrectly here. Yeah, I think I found it right over here. Used a full stop instead of a hyphen. And we'll let that run its scan. And it should enumerate as much information as possible, from the actual Samba service that's running. And again, we'll just let that complete. All right, so the scan is complete. Now it only gives us information, or the only script that actually gives us any information is the SMB enum shares script. So you can see it tells us the the account used in this case was the guest account, and we get an IPC share, which essentially is used for anonymous connections, and that is, as you can see, the path, the default access path is, or the default path really, is under the TMP directory. And anonymous access, we can read and write changes, and then we also have the anonymous share as well as the print share, which again is for printing, to actually share a printer over a network. And the path for the anonymous, for the actual anonymous path here, is under home Kenobi share. All right, so that's something interesting to look out for. Now, if we take a look at the documentation here, it explains a very important aspect of SMB. All right, so when you're referring to SMB and the various ports, because I usually, or it's frequently mentioned that there are two ports, right? You have port 139 and port 445. So on port 139, SMB was, again, originally, as it says right over here, SMB was originally ran on top of NetBIOS using port 139. NetBIOS is an older transport layer that allows Windows computers to talk to each other on the same network. Now, they later on moved on to port 445. As you can see, later versions of SMB after Windows 2000 began to use port 445 on top of a TCP stack. And as you can see, using a TCP stack allows SMB to work over the internet. So that's one of the reasons they actually added port 445, if you're ever confused. And the reason they still have 139 is primarily for compatibility, right? And again, usage of NetBIOS. So using the nmap command above, how many shares have been found? We're able to find 3 shares. So let's see if that is correct. That is correct. All right, so now it's going to tell us we can actually start inspecting some of the shares, or one of the shares rather, and that is of course the anonymous share, which makes the most sense because again, the IPC share, as I've mentioned, is for anonymous access, and the actual anonymous share has a very interesting path, which is it actually tells us one of the users on the system. Even though the SMB enum user script did not give us any users, we can actually see that we have been able to get one user, and that is the user Kenobi. All right, so we can use the SMB client, the SMB client utility on Kali Linux, which I think it actually does come with. And all we need to do is type in SMB client, and we then provide the IP here and the actual share. In this case, it's going to be anonymous. Right over here, we hit enter. It's going to ask me for my password, and it'll give us information regarding this particular share. So it actually logs us into SMB. We can then list out the directory here. You can see we have a file called log.txt, right? And we can actually get this file. So I'm going to say get log.txt. And what directory am I currently in, or am I in currently? I think it has saved it to my home directory. So I'll just move it. It should be under my home directory. So we're just going to say log. Is it actually in that directory? Let's see. Is it under log? I can't actually see anything here like that. So it should have saved it in our current directory. There we are, log.txt. So if we cat out the contents of log.txt, it looks like this is a Samba log, although I'm not entirely sure. Let's actually go through it completely. There we are. So you can see at the beginning, it says generating public private RSA key. It's just a log. A general log of the server. So it looks like this is we have a general log here, and then the basic ProFTPD configuration file. So it actually has that there as well. And now in this particular case, you can see that the user was actually generating a public private key pair, an SSH key pair, and they've stored it under home Kenobi SSH, and the actual key is ID RSA, right? And you can see that it's actually created the directory there, and the password was entered, etc., etc., right? So we have the private key here, and the public key as well has been saved there. All right, so if we go back to the documentation, you can see once you're connected, list the files on the share. What is the file you can see? And that is of course going to be log.txt, right? And we can submit that here. It's now going to tell us you can recursively download the SMB share too, submit the username and password is nothing, of course. I think it was configured that way, but we already have done, or downloaded the log file. So if we say open the file on the share, there are a few interesting things found. Information generated for Kenobi when generating the SSH key for the user, yes. And information about ProFTPD server, which we know is running on port 21 from the Nmap scan, so we can submit that there. All right, so now it's going to say your earlier Nmap port scan will have shown port 111 running the service RPC bind. All right, so that's RPC bind. This is just a server that converts the remote procedure called program number into universal addresses. When an RPC service is started, it tells RPC bind the address at which it is listening and the RPC program number it is prepared to serve. All right, so in our case, we can you can see port 111 is access to a network file system. So you can see we have the access control list for the RPC here. If I can actually go to the Nmap scan, where did I enumerate the Nmap scan? I can just display it here. Let me just exit from SMB here, cat Nmap. There we are. You can see we have the access control list here. And we have RPC, yeah, so that makes sense. So you can also use Nmap, and what we're doing here is we're simply enumerating, NFS or network file system, information regarding the mounts. It's going to list out the contents of the network file system. It'll give us statistics regarding the file system, and it's going to show us the mounts on the file system. So again, all we need to do now is we simply need to just copy this. So I'll just copy this, and of course we'll type in the rest of the command here. So we'll do this within this particular tab here. So we'll just paste that in here. So sudo nmap port 1111 and paste that in there. And then we need to paste in the IP address right over here. And we hit enter. And we can then just zoom in a little bit here so you guys can see what's going on. So I'm just going to let this complete. There we are, it's done. And you can see the volume is under the var directory, and this is the information that's actually contained within this particular mount. So we can see we have various directories under the var mount point, which is the var folder, realistically speaking. And we have the web server, I'm guessing, which is under www, and we have snap, etc. All the typical files and folders you're likely to find within the var folder. So if we go back here, you can see that we can specify the mount that we can see. In this case, it's going to be the var directory or the var mount point. We hit enter, and that is complete. So I think that's done. Let's see what the next step is, because I'm a bit confused as to how this relates to exploiting ProFTPD. But in any case, let's see. So the version of ProFTPD being used, we can get that from the Nmap scan. It's 1.3.5. All right, so let's do that right now. So 1.3.5, and that should be correct. So it's going to say we can use searchploit to find exploits for a particular software version. So that's true. We can say searchploit pro FTPD 1.3.5. I think that syntax will work. Yeah, there we are. So we get various, we also have a Metasploit module, command execution, which I think we can use. So you can see how many exploits are there running. That's four exploits. So let's type that, put that in there. You can see it's going to say you should have found an exploit module from ProFTPD's mod copy module. The mod copy module implements a site copy file and site copy file too. So site copy file from and copy file to, which again these are these are the actual commands that can be used, as it says here, to copy files and directories from one place to another on a server. Any unauthenticated client can leverage these commands to copy from any part of the file system to a chosen destination. We know that the FTP service is running as the Kenobi user from the file on the share. That is correct. So we can just complete that real quickly. And we are now going to copy Kenobi's private key using the site copy from to site copy to. So we are copying the we're copying the actual private key and we're putting it under var tmp id rsa. All right, so now that makes sense. So essentially using the weakness within the actual, if we actually open up the documentation here, you can see this is the mod copy command here, or the actual mod copy module, and the mod copy module implements site copy copy from and site copy to commands, which can, as it says, you know, that's pretty self-explanatory. And it tells us right over here that this module is contained in the mod copy.c file for ProFTPD and is not compiled by default. Okay, so that's interesting. So I think in this particular case that that might be an issue, as you know, that's really why we have a vulnerability for 1.3 versions 1.3 moving forward, and we can actually research more about this particular exploit here. So we can say, you know, if we search for that here, we can see rapid 7, and we have the actual Metasploit module here. So let's try and get an understanding or a feel of what this does, right? So it exploits the site copy from and copy to commands in ProFTPD version 1.3.5. And as a result, any unauthenticated client can leverage these commands to copy files from one part of the file system to another, etc. Right? So in this case, the module will essentially give us a PHP remote code execution, or a reverse shell for that matter. But we're not going to be using this. In this particular case, it's very interesting when you take a look at the documentation here, is that it's actually not compiled by default, right? Which is quite interesting. And in this case, we're simply just using it over here. So we are connecting to FTP, right? And of course, I'm guessing that's going to be anonymous or unauthenticated connection. We can actually try it here. So netcat, paste in, well, that's not the IP. My bad. Let me just copy the IP there. So if we paste that in here, you can see, right? Let's specify port 21. There we are. So port 21. So ProFTPD default installation. And I'm guessing we can list out a few commands. ls not understood, right? So we can only use a few other commands as an unauthenticated user. So that makes sense. So it's not actually giving us any authentication per se. So the first thing we want to do is site copy from. So we're going to say site copy from, and we're copying it from home Kenobi SSH. This is the SSH directory, and we're then saying ID RSA, and then we're saying site copy to, right? And I'm guessing that's under var and var tmp, because we actually saw we have access to that particular mount. That's why I was really confused here. So yeah, it's going to store it under the temp directory. It's going to do that for us. So we're going to hit enter, and whoops, looks like we have an issue there. Let's see. Well, yeah, we actually have to provide a file name there. So site copy to, my bad, var tmp and ID RSA. Bad sequence of commands. I'm guessing I'm going to have to repeat that. So we're copying from. Whoops, my bad. That's file directory exists. Let me just do that one more time. So site copy from. Okay, invalid command, and site copy to. Let's paste that in there, and the copy is successful. All right, so that's done now. If we take a look at the documentation here, we knew that the var directory was a mount. We could see, task 2 question 4. So we've now moved Kenobi's private key into the var tmp directory, right? So that's completed. So now we can actually mount the actual mount point, which is under Kenobi. So we need to create a directory first where we're going to be mounting this particular mount, or file system for that matter. So we can say sudo. Let's create a directory. So we're going to put it under mount or mnt. The mnt directory on Linux is the the de facto folder or directory where you should actually be mounting any storage volumes, etc. We'll just call it Kenobi, right? All right, so that's done. So now what we want to do, let's just copy the IP address over there. We actually want to mount the var, the actual var mount network file system, as it were, into the mnt Kenobi directory that we just created. So we're going to say mount. We're going to paste in the IP over here. and we're going to say, the var directory or the var mount point, and we say mnt, that's where we're mounting it. So we're going to say Kenobi, hit enter. That looks like we have an issue there. We'll use sudo here, and that should do it for us. All right, so I think that's done. If we list the contents of the mnt Kenobi directory now, so, or the actual the mounted directory, you can see we have the tmp directory, and again we can access that right now. So if we list out the contents of the mnt Kenobi tmp directory, you will be able to see that we have the ID RSA, or the actual private key for the user Kenobi. So that makes sense there. So we now have a network mount on our deployed machine. We can go to the var temp directory and get the private key and then log in. All right, so we need to use that key. That makes sense. So we're going to say sudo copy, and we say mnt Kenobi, and we're going to tmp ID RSA, right? That's the key. We'll just copy in our current directory there, and that's done. We can then say, we can give it chmod 0400. I think that should be fine for the permissions. There we are, and we say ssh ID RSA, and then we say the user is Kenobi, and we need to copy in the IP address there, which I'll do, and we can paste that in there. We should be able to log in, I'm guessing. Let's see if that works out. It's asking us for a password. Let's try and use sudo here, because that should work out. Invalid format. Do we have to convert the key? Not really sure. No, we actually get logged in as the user Kenobi. You can see we're currently the user Kenobi. Let's take a look at the distribution that we're currently on. So we're running Ubuntu 16.04 Xenial Xeras. Okay, so that's fairly simple. We can now enumerate the user flag, which is under this directory. So we can say cat user.txt, and we get the user flag right over there. All right, so we paste that in there, and looks like we're done with this particular section, or the third task. And now we are taking a look at privilege escalation with path variable manipulation. All right, so this is interesting. All right, so there's a really good description or image here that explains how to identify really SUID binaries, SGID binaries, and what sticky bits are, right? So it's fairly simple to understand by looking simply at the actual permissions and what you should be looking for, right? So you can see SUID bits can be dangerous. Some binaries, such as password, need to be run with elevated privileges. That's because it's used to reset or change passwords for different users on the system. However, other custom files could have that SUID bit, can lead to all sorts of issues. To search a system for these types of files, we can use the following find command, which again is fairly simple to understand. And again, we can use that, or we can also use an automated enumeration script, which I actually wanted to introduce in this video, and why not? Let's do it right now. So the tool I'm talking about is linpeas, right? So I'll open up the GitHub repository here, and there we are, linpeas. This is a Linux privilege escalation awesome script. What it does, it essentially searches for possible paths to escalate privileges on Linux, Unix, and macOS hosts. The checks are explained in the following documentation here, or that particular web page. And again, using it is fairly simple. You just need to clone the script, and you can then copy it to the target really easily. So let's actually run this before we run the manual command. So what I'm going to do is, I already have the script. So I'll just close this tab here, and we'll head over onto my desktop, and we'll go to Linux enum. And we have it right over here. So we have linpeas.sh, right? And we'll use a Python module to set up our web server. So Python 3m http.server, and we'll run this on port 80, right? And IP, let's get our IP address here. The tunnel IP address, or the interface IP here is listed over here, so we'll actually need that. We'll go into the temp directory on the Kenobi system, or on the target rather, and we'll use wget to actually get the file, so from a local system. And we'll then say the script name is linpeas.sh. And yeah, looks like we can actually download it, so we get it there. And we can then say chmod +x linpeas.sh, and then we can execute it like so, linpeas.sh, hit enter, and that's going to begin enumerating. Now there are various options that you can actually use with linpeas to limit the results to certain checks, right? Or to limit the actual searches to a particular criteria, which you can actually take a look at using the documentation. I'll probably be making an individual video to cover winpeas and linpeas because of how important they are. As you can see, there's going to be a ton of output, and what I'm going to do is I'm just going to let it go through all of this, and you can actually see right over here, it actually finds the SUID binaries here, and of course it'll check for easy privesc, exploits, and write permissions, and we can go through all the the various binaries. Now if we take a look at the documentation, I just want to highlight something here. You can see that we're looking for the SUID sticky bit, right? You can see it that it's applied on all of these, or mostly some of these binaries here. So the sticky bit for SUID is listed right over here for this one, or for most of these ones right over here. And you can see that these are all being all owned rather by the root user, which is interesting. And linpeas will of course list out any potential vulnerabilities or any information regarding the binaries that it's actually found, and vulnerabilities within those binaries per se. So we'll get to that in a second. So I'm just going to let this complete. All right, so the actual linpeas script has completed. I think it should be done now, and you can see there's tons of information, which is why, again, as I said, I'm going to be making an independent video on this. But the important thing, if we go back to the SUID binaries, I just wanted to make sure that that is done. If I can actually scroll to the SUID binaries here, this is going to take a while. There we are. So you can use automated enumeration scripts like this, or you can use your manual checks. Now, if you take a good close look at it, these are pretty standard binaries that you would typically find. For example, you have umount and mount. These are the mount and unmount binaries. But if you take a look at the bottom here, linpeas will actually tell you there's an unknown SUID binary. Now, this is in most cases. On properly configured systems, you shouldn't be finding any binaries like this, but in this case, because we're dealing with an educational machine here, you can see that this binary looks interesting because it's a new one that's you'll typically not find on a standard Linux installation, and that is user bin menu. So the binary is menu, right? And it's owned again by the root user, which means when executed, it's going to run with root permissions. And we know it is an SUID binary. Now, we can actually try and execute this binary. So if we say menu, you can see that it gives us a menu here, which is interesting. And the first option is status check. Let's actually take a look at the documentation here. And by the way, you can use the manual search options here, which I have covered in the past. So it says what file looks particularly out of the ordinary. I'm just going to say what I think, right? So user bin menu. Let's see if that's correct. I may be wrong. And yeah, I am correct. All right, so run the binary. How many options appear? We can see that it has 3 options. So it runs it as root. We know that already. We can actually confirm that. So lsal user bin menu. And you can see it runs it as the root user. There we are. So that's fine. Let's run the menu command again. So we know we have 3 options, and it simply runs, some very basic commands. We hit submit. That is correct. So it's now telling us to perform a little bit of reverse engineering as to, to perform some very basic reverse engineering. I should actually correct myself there, using the strings utility. So again, we can explore the actual strings that are found within a binary. Of course, we don't have the code, but we can say, for example, strings user bin and menu, like so. and this will give us the various strings that were able to be found. And you can see the three commands. We have the various commands that they run, which is fairly simple. Localhost curl I, which is checks the status, kernel version, uname R, pretty standard, and ifconfig, which is again a typical Linux command. But one that is interesting is the curl command. But let's take a look at the documentation here. You can see this shows us that the binary is running without a full path, not using user bin curl or user bin uname. That's true. So the utilities are not using the actual relative paths, right? So all of these binaries, you can call upon them, but the way Linux works is when you type in a command like ifconfig, it actually checks your environment variables and it'll check the path environment variable for your particular session, and that path environment variable will actually tell will tell Linux, or rather Bash in this case, where to look for that particular binary, right? So for example, if I type in the environment variables for this particular user, you can see there we are. We have the path variable, and in this case it starts off with home Kenobi bin, or the actual binary directory for the Kenobi user, home Kenobi local bin, user local s bin, user local bin, user bin, etc., etc. If we take a look at the documentation here, you can see it tells us that we can manipulate the path to gain a root shell. But what are we exploiting here? Well, as it says right over here, we copied, it actually does this within the image here. We can create our own curl binary, as it were, and put in a simple bash command that when executed will give us an elevated session because the menu binary is running as the root user. So again, we can use any, I think we can actually use any of them here, but we can use the example here. So what we're doing is, within the temp directory, we can simply say echo, and we say bin sh, and we can then export that into a file called curl, or rather the binary, and then we give it some executable permissions, 777 curl, right? And we have given it the executable permissions. We can then export our path variable, as it says here, and change the actual path to the temp directory. Now the interesting thing here, or the thing that you should note here, is this is quite interesting, or a very, very interesting way of doing it, and one that is not really recommended, because you can easily lock yourself out because you're changing the environment variables. You're changing the path, which means you pretty much will not have access to any of the other binaries. So that's something that you need to take close. You need to actually consider in the future. This is not the correct way of doing it, but in any case, so path is going to be set to tmp, that's the temp directory, and then we are simply going to say path. We're going to specify the path there. We hit enter, so that's going to do it for us, and we can then launch the menu utility or the binary, and we're going to run the first status check, which uses curl. And again, because we specified our environment variable as the temp directory, it's going to use the curl binary there. So if we hit 1, you can see it's going to give us a born shell, or a shell session rather. We hit ID here, we can see we are currently the root user, and if we head over to the root directory, you can see we have the root flag here. So root, sorry, not root flag, or rather root.txt, my bad. And we can get the root flag right over there, and I think that's pretty much it. There we are. So we can complete that one and paste in the root flag there and hit submit, and we should be done. All right, so that was Kenobi on TryHackMe, an interesting machine, I should say, or an interesting room for that matter. Very interesting challenges. I really like the fact that they, teaching or actually covering SMB enumeration, especially on Linux, because Samba can be a bit confusing, especially when you move on from Windows to Linux. Although the differences are quite few and far in between. But we also have privilege escalation, which is something I wanted to cover, and of course I'll be covering them in depth with other vulnerable systems in the future. But TryHackMe is a great way of actually getting started with some of these techniques. Although as I have pointed out before, they give a ton of documentation that you typically have to go out and research. Then that's not entirely a bad thing. But again, you can also, for the exploitation phase, you could also have used the Metasploit module, but it's also good to actually go through this manually. That being said, that's going to be it for this video, and I'll be seeing you in the next video. A huge thank you to all of our Patreons. Your support is greatly appreciated, and this is a formal thank you. So thank you Shamir Douglas, Ryan Carr, Sandor, Michael Busby, Sid Saab, Doozy, Tafim Bari, Dustin Umpress, and Michael Hubbard. Your support is greatly appreciated, and you keep us making even more high quality content for you guys. So thank you.